All right, so we see this one, the workshop of the future week. Next week is the university. There is no class next week, so it doesn't mean holiday. It means you need to catch up. You need to study. It's about the end of the semester, so you need to, uh, if you are behind from any course, you need to catch up. Okay, so the direct formula has been given. The direct solution of the linear. You see that an equals to b times an minus 1 plus c. So it's this one and this one. So this measures the anytime, every month, how much you owe to the bank. For example, according to the question 1. So if you want to buy a home or mortgage, anything else, so there's interest rate for sure. So this is the place that you can calculate what have you done. Okay, so here a and b times an minus 1 plus c. So the direct solution is this one. So you can, if you don't know the direct solution, you need to use the induction. Put it inside the for loop formula, and yeah, you will be able to handle it by using for loop and computer. So, but direct solution is also very good one because you don't need to the previous terms to get calculated. You can calculate directly. So apply the recurrence formula, recurrence in the box here, in the above the following banking problems, and determine how much money you will have after 12 months in each situation. I mean, you don't owe, so like this one is, if you want to buy, it will be negative. If you want to, if the bank wants to pay, it will be like this one, 1% in, what do we say that? 1% profit or whatever. 1% profit. You put money in your bank and uh, interest is, I feel that there should be another word for that. WhatsApp is there. Pardon? Are you talking to me or? Okay. Anyway, monthly fee $10, $20. So let's have this formula. With this one, for the first one, an equals to an minus 1 plus. What's speed here? It adds 1% money. So $1 every time. So how much money do you have? So you have got $1,000, for instance. So it adds 1,001.01 times 1,000. So let me amend what I said. Okay, so it will add 0.01% of this money to your previous money. But unfortunately, there is a fee. Fee is not a good thing. Okay, so it means negative. minus 1. So this will be minus 1, C, and this will be what? Part B. What will it, this one, what will it be? 1.01 of the previous one. So this one is 0.01 times 1000 plus 1000. So if you factorize 1000, it will be 0.01 plus 1, 1.01. So that's why this is B, this is here appearing from, it's, we get from here. So if you want, so now B is 1.01, C is -1, unfortunately. So we will apply this formula. After 12 months, A12. So A12 is equal to here 1 point, what's A? What's your initial money? Yeah. Plus C is -1 plus B is B is 1.01 over 12 minus 1. Pardon? 1.01 minus 1. Yeah? It's not. Which one do you say? This one? Here? This one? Which one do you mean? Ah, sorry. Which one do 1.01? This one? Dot? Yeah, dot. Yeah, 1.01 power 12 minus 1. Yeah. Huh? I have not written 1000 now. Which one? Cursor? This one, yeah. I wanted to show that here is written 1%. Say we have $1,000. So next month, the money that will be added to us is 1% of this much. So it will be, so this one to be added this one. So then I factorize 1,000 and it will be this one. 0.1 this guy plus 1. So this one together will be my B. So B comes from 1 month. Yeah. But there is minus 1. Yeah. All right. So this will be the answer of this one. You can calculate this one. So you can do the same job part B. The only part B, the only difference, the C here part B is instead of to be minus 1, it will be minus 10. Yeah, minus 10 and C, the other part C will be C minus 20. Okay, is there any question about this? Okay, so the first part, it says that this one, 1% adding, so it is positive 1.0.1, but this will be $1 fee, so it will be negative 1. So part B, C will be negative 10, part C, C will be negative 20. Okay, so let's do now. The question after this is Hanoi Towers. So I won't do that because we don't have time. More importantly, we will do the better one. Question. Yeah, just a moment. Yeah, what's your question, please? Huh? Yeah. And what do you write after at the last part? You wrote -1, stays -1, but because it's a mistake. It's a mistake. Yeah, I wanted to someone tell me. It's not. Yeah, times. Will be times. Okay. So question 3 is you will have exactly one question from here in your final exam for sure. So you see this one here. So Sn n minus 1. What's the order of this one? Over 2. Order is 2. 2. Yeah. So order. I am asking about my question is about the order. The order is 2. N minus 2. But there is plus 1. So if in my recurrence relation, if there is a term which is not related to the S, N or S index I, S index anything, n plus 1, n minus 1, something like that. So this one is like that term. So this means this recurrence relation is not homogeneous. So to solve this one, uh, you will solve homogeneous part. Okay, homogeneous parts, and you will solve a particular solution. We know how to solve the homogeneous part. So the characteristic equation of this one, as you said, equals to R plus, it's not writing, plus 2R, yeah, R plus 2, just a wait. R plus 2. And the particular solution, it depends on the type of the non-homogeneous part. All right, so the non-homogeneous part, for part B, non-homogeneous part is this one. For part C, the non-homogeneous part is 3 power n. Is there any ambiguity about this? Is there any question about this? Did you understand what I said? Use C, yeah. So, for the general solution, you will solve firstly this part, homogeneous part. Ignore this part. So ignore this part, this part. Okay? Okay. So once you found the homogeneous part, would you please sit there? Yeah, excellent. Yeah. Let's find this one. So it's easy, yes, because we practiced a lot. So if we find this one, r squared minus r minus 2, r from here, r equal to r, or yeah. So this will be, what's the solution of this part? Sn C1 2 power n plus C1 2 power n just a moment. My pen doesn't have charge. So anyway, so do you see the pointer here? So uh again, we will solve the homogeneous part. Okay, we will for a moment for a moment we will ignore these non-homogeneous terms. Okay, Hello, brother. What are you doing there? No. Yeah. Where is your phone? I can put you present and you can, if you want, you can leave. Or if you want to use this class, please come and sit here. Yeah. We will solve the homogeneous part. We will ignore these non-homogeneous terms. Once we solve here, which I'm going to write it now, then here, Sn, but it's not sufficient. Okay? So we will write Sn, the general solution, plus the particular solution. The particular solution, it's delicate. It depends. We have to treat, it depends on the type of non-homogeneous term. Ming, do you want to say something? Yeah. Okay.
Don't know how to speak.
Yeah.
Yeah, but it means square, and
Yeah.
and miss this.
Yeah. We miss.
This part.
Yeah. Yeah.
Yeah.
And yeah, excellent. So, and also, do you see that the homogeneous part of these guys are the same? Yeah. We have to solve just one time, then we will copy. Okay. Look, this will be C2 minus 1 power n for this part. Now, one non-homogeneous part. Now we are going to update this one by plus particular solution. Particular solution for this one depends on the non-homogeneous term. So if it is constant, we will apply the particular solution will be in this type. If it's a polynomial, like this one, n plus 1, it will be like this one, C1 plus C2. If it's n squared, n power 3, we will move until the n power that number. So here is n power 1. So we will write C1, C2, n power 1. We won't write C3. In fact, the particular solution should look like to the term of the given in the non-homogeneous part. Now here it's b power n. Okay, so it should be c times b power n. If it is f of n, it should be something similar to f of n. All right, so for 3 power n, it will be c times 3 power n. So let's find this guy d. It's a constant one, so the particular solution will be d. Therefore, particular. What are you doing there? Okay. Solution Sn. Following the instruction here, Sn. All right. So if Sn is equal to D, therefore Sn minus 1 is D. Therefore Sn minus 2 is D. So it's equal D for everything. So part A, Sn minus 1 plus 2 times Sn minus 2 plus 1. D equals D plus 2, D plus 1. Now let's find D. So cancels, and from here 2D plus 1 equals 0. From here D equals to minus half. So the particular solution's answer is minus, D is minus half, so Sn is minus half. From here, the general solution for the non-homogeneous will be Sn, homogeneous part, plus particular solution. Pardon? Then we will see it will affect here D plus 2D plus 2. So then we will solve accordingly. Plus 2, it will be, so let's do. If it's 2, this will be 2, this will be 2, this will be, then D will be minus half. So this will be minus half, minus 1. Okay, so now part B, Sn minus 1 plus 2 Sn minus 2, the same homogeneous part, plus non-homogeneous part is plus, let's put it inside a bracket. Which one? Here. D2. Excellent for correcting me. Now, here again, Sn is already C1 2 power n plus C2 minus 1 power n because the homogeneous part is the same. Otherwise, we needed to write particular solution. Particular solution. Sn. So since it's n plus 1, what's that? Look at this one, a polynomial of order m, and the situation case particular solution will be C1, C2 until n power m. Okay, so I will do the same job. Sn will be A plus B times n, because this guy is degree 1. You discover n power 1 plus 1. A plus B n. So if Sn, so again, we go to substitute this Sn here, to here, to here, to here. Sn minus 1 is equal to A plus B times n minus 1. Troy, Sn minus 2 equals to B times n minus 2. Yes. Yeah. Dear students, assignment 2 is available. Okay. Is now available on Canvas. It is due 2 weeks from now and is to be submitted via Canvas. Congratulations. Okay. So next week is not really holiday. It's a time that you need to catch up with the course. What's your question? Sorry. Previous what? Mathematics.
Yeah.
Part A. Yeah.
Yeah. Why did you cut 1?
Because she said that what if it was 2?
Oh,
Because She thought that whether this one is, oops, whether this one is 1 or 2, d will be always minus half. But in the calculation of d 2d plus 1, if this one was 2, the d would change. How was my English grammar? Yeah? Okay. D would be different. So A plus, so slowly I wrote these things. Oh, so now can we substitute these ones in the original whole recurrence relation, including n plus 1 should be involved. Then we aim to find A and B. Okay, so A plus B n A plus B minus 1 2 times A plus B n minus 2 Muhammad. Yes? Yeah. Oh, when I say Muhammad, several people looking at me. Okay. Good. Excellent. What's the other? Monitor number 7. I don't know the name. Hi. Are you okay? All right. So go outside. But you should not. I'm saying that have your concentration and don't play with your phone and you answer your phone call. That will be a misconduct. In the morning, I asked someone to leave the classroom. Don't do that again. All right. So where we were. So this one, this one. Okay. Plus n plus 1 without like okay. I hope these coloring the highlighting the content text will help you. So now what we have now, so put them together. So the only is this one from here to here, a plus b n. I just want to multiply inside plus b n minus b plus 2a plus 2b n minus 4b plus n plus 1. So let's cancel these things. Okay. I wanna cancel this one. Did I forget something? And I will cancel this one as well. What do we have now? Uh, what should I do? I will write minus b. I wanna, yeah, a, yes, yeah, excellent. So I will gather these ends together. Plus 1 plus 2b plus 1 times n equals 0. Are you happy with this one? Did you huh? Did you understand this one? Yeah, you're okay? See, minus b is written here. Plus 2a is here. Minus 4b is here. Plus 1 is here. Then 2bn is 2b times n here. And 1 times n is here. And everything equal 0. Okay? Yeah? So, uh, from here, 2b plus 1 has to be 0. The coefficient of n has to be 0. B is negative half. From here, putting them together, minus 5b. Yeah, this guy and this guy is minus 5b. All right, and plus 2a plus 1 equals 0. So, minus 5 plus, uh-huh, uh-huh, from here. So, this will be together 5, 2, this here, plus 2a plus 1 equals 0. From here, 2a equal. Adding negative 1 both sides and negative 5 over 2 both sides. So negative 1, negative 5, minus 5 over 2. Negative 1 is equal to negative 2 over 2. So it will be minus 7 over 2. So from here, a negative 7 over 4. Now let's update our this guy. Particular solution has been found. Sn is equal to what was it? Here, C1 power n, C2 minus 1 power n. Is that minus 1? Yeah. Particular solution minus 7 over 4 plus b. So do you remember that we chose Sn to be a plus bn? A is minus 7 over 4 and b is minus half. So this will be minus 1 over 2 times n. This is the solution of, okay? Yeah. There any question about this? Do you want me to explain anywhere? We can do part C as well. So part C, 3 power n. And when the Sn This is the first one is just nothing, homogeneous part plus. The non-homogeneous part is like something power n, 3 power n. The particular solution will be C times B power n. Yeah? Question 3 part C, S, N should be C times B power n. I am writing this one C times B power n. B power n, 3 power n. B power n, 3 power n. Did you understand? So since the homogeneous, non-homogeneous part is 3 power n, the particular solution is C times 3 power n. Our task is to find C. Okay, so this will be C times 3 power n. If this one is n, then Sn minus 1 will be C times 3 power n minus 1. Sn minus 2 will be C times 3 power n minus 2. So just remind you that Sn minus 1, 2Sn minus 2 plus 3 power n. Am I right? So I have Sn minus 1, 2Sn plus 3 power n. Yes. So by using this one, substituting, I don't want to do coloring again. C times 3 power n, C times 3 power n minus 1, 2C times 3 power n minus 2 plus 3 power n. Let's divide both sides by the lowest power, 3 power n minus 2. Okay, so this will be C times 3 power n, C times 3 power n minus 1, 3 power n minus 2, 3 power n minus 2. Okay, what's this one? 3 power n over 3 power n minus 2. Just put, if you don't, if this one is hard, if you experience just hard time, just put n equal something, n equal 2, maybe n equal 3, and get the answer numerically to me. Yeah. What's that? Yeah, what? 2 and plus 2. Do you know that? Do you know that? What's this fraction?
Minus
So what's that? Huh?
1 minus 2. Figure it out minus 2.
Okay. What's this one? What's this one, Muhammad? What's this one? But allowed, pick allowed. You don't need calculator. Okay. What is n equal 3? 3 power 3 over 3 power 3 minus 1. 3 power 3, 3 power 3 minus 1 is, sorry, this is 2. 1. Huh? Yeah, 9. Okay, so I think I should remove this part of the video from the YouTube, yeah? Because it's just primary school question. Okay, so all right. C times 9. What about this one? Yeah, why is it 3? N minus 1 over 3n minus 2, 3 power n minus 1 times 3 minus n minus 2. 3n minus 1 minus n plus 2. What's this one? Power 1, 3. C times 3 plus 2 times C plus. And this one has been discussed. 3 power 2 or 9. So let's C9 or 9C minus 3C minus 2C equals to 9. 4C equals to 9. C equals to 9 or over 4. Yeah. So Sn equals to 9 over 4, 3 power n. So the general solution for the non-homogeneous solution recurrence is 9 over 4. Okay. Okay, 3 power n plus C1. What was this one? 2 power n plus C2 minus 1 power n. Okay, so is there any question about this? Is there any question about this? Uh, 25 questions. Yeah. So up until question 3 is just recurrence relation. Then new topic is starting from the question 4. It's called counting. Is there any question about this? All right, so yeah. There again. Again, any question? Yeah. Do you have question? come and show it here.
Okay, like this step here means like this minus
Yeah, n minus n.
uh,
Yeah, n minus n plus 2. So minus goes inside.
Okay.
So this will cancel this one, so it will be just 2.
Okay.
Hmm? Uh, okay, let's, okay.